it was just like a giant futon. That was it was a big Snorlax, and you just basically go climb on it, and it's just like sleep right there. I thought you had an appointment today.
What?
I thought you had a doctor's appointment today. I thought that's what you told me the other day. No? Okay. All right. Hello?
Hello.
Shalom.
Buenos dias.
Konnichiwa.
I can't hear you. It's too dark.
Ni hao. All right. What did I tell you guys yesterday? What is the first rule you have to do when you get one of these problems?
Read it twice.
Twice. From each corner of a square piece of sheet metal, 18 centimeters on, so it's a square, so it's 18 by 18, right? Okay. On a side, remove a small square and turn up the edges to form an open box. What are the dimensions of the box with the largest volume? Okay. So we know, let's go through my information. Square piece. Okay. 18 centimeters. Open box. And I know I'm going to come up with volume. So I'm going to start off with there we go. And I know that it's a box 18 by 18, right? Okay, so and now I know I'm going to do this. I'm going to cut out a piece on each corner, and I'm going to fold that up to make an open box that will have volume. And it's right here. So remove a small square to turn up the edges to form an open box. So I'm removing a small square. Do I know the dimensions of that square?
No.
No, I don't. But it's going to be a square that I'm cutting out, right?
Yep.
So it's basically, it's going to be an X here. It's an X here of I don't know. And so, same thing all the way across, right? X, X, right? Now, I know that the length of the side, what is the maximum X could be?
17.
Try again.
16.
Nope.
18?
No, because you need to cut some of it off, right?
Oh, yeah, never mind.
What is the maximum? Okay, now let's start this over again.
Oh, one side.
It's a piece of metal, right? What's the dimensions on the side?
18 by 18.
18, right? Okay. What am I doing out of each corner?
Cutting some off of each one.
Cutting some off each corner, right? So what would be the maximum I could cut this off for X?
Oh, the max you can cut off. Oh, okay. So you off towards like 1 centimeter. So you cut off 17.
Nope.
Do you want a number? Or?
Give me a number for X.
Oh.
8?
4. 2.
I'm just thinking about realistically. What is the domain of my X values? Can it be 0?
No.
No, it can't be 0. What would happen if it's 0?
And you wouldn't have cut anything off.
And I wouldn't have any volume, right? That's important to think about. Can it be 18?
No.
No.
Can it be 16?
No.
Yeah. Can it?
No, because we cut off 16.
Well, if it's both of them. Like,
Because
That's
can you cut off 16 off both X's?
no.
Can X be 16?
No,
Oh,
when you
no.
go over your limit
No.
of 18.
So this would be 16 and this would be 16.
No, that wouldn't work.
no,
So can that and that both be 16? No.
So
9. Okay. Think about it. Think about it. So, can it be 9?
No.
But then you're just gonna like that whole
Yeah, then you
side
cut
off.
off.
Then I'd cut the whole side off, right? So again, there would be no volume. Yes, I love it. We started before, we're actually kick off before anything. Okay. Okay. Yeah, you want to come by later today? What lunch you have?
I can come back, what lunch you got?
I got fifth lunch.
I can come.
Okay.
Appreciate it, thanks, I didn't mean to interrupt.
No, no problem.
Thanks.
Okay, so I'm going to talk about volume real quick. Let's see. So volume would be length times width times height. Right? So if I cut off 9 from both sides, I would cut off the whole side, right? So I would not have anything left, right? So what would the volume be? It would be 0. Thank you. It would be 0. The volume would be 0. So I cannot have that. So my domain of this, the realistic domain, would start from,
0 and then back, right?
can't be 0 though,
So
right?
it's gonna be 1 plus.
So it's got to be, the domain of this would be between
bigger than 0,
greater than 0, right?
less than 9.
Okay,
0
and less than.
x, which is less than 9.
So it's got to be there realistically, because you have to think about the numbers of what it's going to be, what it can be, and that's going to help you out, because when you're getting this and you look at it and you think about it, be like, okay, now I could actually start doing something like this. Now I could, apply this somehow. So what would be the length of this going to be? So what would be the length of this side?
18 minus 2x.
18 minus 2x, very good. So this side right here would be 18 minus 2x. Okay? So the area is going to be what?
Wait, the 18 minus 2x is for the little squares? Or
No, that's the whole thing, because I'm cutting off one of the sides.
That was 18 minus 2x and quantity squared.
Okay? So now I'm going to redraw this. I think I have another page here. Or, yes. Okay, so I'm going to redraw this, but now I'm going to draw this in 3-dimensional.
Looks like a book.
All right. So I know that this side right here, okay, I'm going to start plugging in my information. Since it's supposed to still be a square base, right? Then I know that this is 18 minus 2x. Yes? This is 18 minus 2x, right? And the height of this is going to end up becoming x. Because I'm going to cut off something, and when I cut it off, that's what I fold up there. Where I cut it out, that's the fold. That's the fold right there. So this piece right here, just right here, this right in here, folds up and will be the height of my box. Does that make sense? Anyone questioning what I'm doing? Okay, we okay? Okay, so I'm looking to maximize the what?
Volume.
Volume. Very good. I'm maximizing the volume, so I'm looking for the maximum volume out of this, right? Okay, so let's go over. Now, the formula for the volume is length times width times height, right? Length times width times height. So now, do I have values for all these? Yes, I do. I have a length, I have a width, right? And I have a height. So I'm going to go V equals length 18 minus 2x times right here my width, which is 18 minus 2x times the height, which is x. Did I confuse anyone yet? Is it making sense? Is it a little bit? Okay. All right. Okay, so now let's get one function out of this. So expand this. So if I expand this, so do my distribution, right? V equals 18 times 18.
324.
324. Okay. So 3, 2, 4. Right? So this is 36 times 2. 72x. Thank you. My brain's not working this morning. Plus. Wow. I just felt that one right there. Right there in the back as soon as I turn around. Okay. All right. So go ahead, distribute that last x. So v equals 3, 2, 4 x minus 72x squared plus 8x. Nope. 4x. 4x cubed. There we go. So again, we were maximizing the volume. We're maximizing the volume, right? So if we're maximizing the volume, that means I need to take the derivative of the volume. And I have the volume formula here. So it's dv dx is equal to 3, 2, 4 minus 144x plus 12x squared. Where'd I get the what? Yeah, 2 times 72. Okay, maximizing this, I know that the derivative has to be equal to 0. Okay, so I'm going to get 0 equals 3, 2, 4 minus 144x plus 12x squared. Okay, so we got to try and factor this now. Hopefully by 12. I don't want to mess with those big numbers. Is 324 divisible by 12?
Yes.
You get what? 27. So it's going to be 0 equals 12. Take that out. So it's going to be, you said 27? Minus 12x plus x squared? Yes? Okay, good. So the 12 will go away because I could factor that out. Okay, and so now what are the factors of that? That's 9 and 3? 9 and 3, yes. So it's going to be, let me see.
Isn't it negative?
Yeah.
Negative 9.
Negative 9 plus x and negative 3 plus x. Yeah, there we go. And so therefore, I'm going to get x equals,
Positive 9 and positive 2.
yep, Now, there's a reason why I wanted to talk about the domain at the beginning of this. What's the reason I wanted to talk about the domain?
Because 9 is in the domain.
Is the 9 in my domain? No, 9 is not in my domain, is it? Because right here, if x is 9, that means I just cut off the whole side, right? I cut off the whole side, so one of my values, my length or width, will be 0. Okay, I'll get a height, but not a width. Okay, so now for that one, I know that x has to be 3. Let's go back to the question. What are the dimensions of the box with the largest volume? So, if this is 3, right, let's fill in the blanks. So, this is going to be 3, this is going to be 3, so the space in between
12.
is going to be, so this is 6, right? This is 12. So my box, my dimensions of my box, so 3, 12, and 12, and those are in centimeters. There we go.
Can you go back to the other slide?
Yeah. Alright.
This was on the test when you have to, like, if that's for dimension, when you have to put length equals this, width equals this, and height equals this.
Yeah, but for this one, it's length and width are going to be the same. AP exam, if you were to draw a diagram like I did, then put everything where it goes. Yeah, that still works too. Yes.
How'd you get 18 minus 2x?
Okay, I started off with right here. Okay, now I know the whole side is 18, right? But I'm cutting off a piece, a square, right? Out of each corner. So this is an X right here, right? And this is an X, right? So I don't know what X is, but I know that the whole thing is going to be 18, right? 18 minus 2 times whatever I'm cutting off on this side. That's where I got that from.
What if you weren't cutting it off? What if like you were like adding it on? Would it be like plus?
Yeah, it would be plus. So it would be 18, what I know,
Yeah.
plus 2 times the unknown value. Yes. Okay? So yeah, since we are cutting it off, it was minus whatever that is. Anyone else? We good? Okay.
Now we're gonna just multiply everything together. Get the volume.
No, what are the dimensions of the box with the largest volume? Yeah.
Okay.
It didn't ask for the volume, it asked for the dimensions of it. Okay. Don't forget, like, subscribe, hit that notification button.